at the bottom of page 32, they give you the formula for the general term of any geometric sequence. This formula is on your formula sheet as well. And we kind of already discovered it in our 1,000-layer pastry thing. Because you have your first one, then you have to multiply your second one times r once, then you're multiplying by r twice, then r 3 times. So whichever term you're finding, you would have to multiply by r by 1 less than whichever one you're finding. So that's why it has an r to the n minus 1. And we're going to use this formula lots when we do questions as well. So if we look at example 3. In a finite geometric sequence, term 1 is 7 and term 5 is 567. So we don't know what the r is yet. However, we could use our formula and say, I have enough information to plug in everything into this formula except for r. Why? Well, I know that term 1 is 7. I don't know what r is, but I also know that term 5 is 567. So if I put 5 in for n, term 5 would be here on the left side. And now I'm going to need to get r by itself. So I'll divide both sides by 7. Anybody know how to get rid of a power of 4?
Square by 4.
It's close wording. You're saying the right thing.
Square rooting.
Square rooting is when it's a 2. Fourth rooting is when you do, like, we would do this on both sides. Fourth root of this side, fourth root of this side. And just like square rooting, if you have an even number, your r value is going to be plus or minus, and since 3 times 3 times 3 times 3 is 81, the fourth root of 81 is 3. So we get r is plus or minus 3. So then if we want to find out term 2 would either equal 21 or negative 21, depending on whether you use the 3 or the minus 3. Do they say both answers at the bottom of the page? Good. Okay? And if I wanted to find term 6, does it make sense that I didn't use the formula for term 2? If you know that you're multiplying by 3, you can do that in your head. Okay? Term 6 should equal, if I use the formula, term 1, which is 7, r, which is 3 or minus 3, I'll do it for plus 3 first, to the 6 minus 1. Type this into your calculator all at once, and apparently we get 1,701. And if you did it with r equal to negative 3, does it make sense? Because it's a power of 5, you could also get term 6 to be negative 1,701. When finding a value where the question uses the words the last term. Okay? So this question here says, the last term is 45,927. So what we're going to do here, we're going to plug in the last term for the Tn and solve for n. We don't know what n is, but we know what the last term is. So we know there's going to be a term something that's equal to that 45,000 number. This is probably the most abstract part of this unit, that you're sometimes plugging in something for Tn even though you don't know n. Tn and n are different things. Tn is representing some term. It could be the 5th term, it could be the 7th term. Here we're thinking of it as the last term. Whatever you plug in for Tn, when you solve for n, it tells you where it is, what position it's in. So if I go to the formula, and I'll write out the formula, the general formula looks like this. And I plug in the 45,927 for Tn. I know term 1 was 7. And I could either use 3 or negative 3 for r. I'm going to use 3 just because it's a positive number. N minus 1. So divide both sides by 7. And we get 6,561 equals 3 to the n minus 1. Now, unfortunately, you have not learned any mathematics up till now that lets you type something into your calculator to figure this out. And to make matters worse, I have to tell you bad news. You will not learn how to do that until grade 12, pre-calculus. All we can do right now in grade 11 is do a little bit of educated guess and check. First of all, if this is, if this is a term in the sequence, does it make sense to you that n has to be a nice number? It can't be 7.2. It has to be a whole number. Because in a sequence, you're not like, oh, I was at term 5.5. What? There's no term 5.5. There's only term 5, term 6, term 7. So we know that n has to be a nice number. Okay? So let's, educated guessing and checking. Let's see what 3 to the power of, let's see if my calculator responds first. That's not good. Try 3 to the power of 5. Is it 6,561? I hope I picked one that doesn't work. Is it too small? Good. So try something bigger. Try 3 to the 7. Is it working now? Oh, it is. Here we go. Here we go. So I said try 3 to the 5. Wow. 3 to the 5. Too small. So I'm going to go bigger. I'm going to go 3 to 7. Still too small. Don't go crazy. Okay? Like, I was getting close. Do you see that would be a bad choice to jump all the way up to 231? This might even explode my calculator and say it's too big for, yeah, it can't even, it's like too many numbers even for my calculator. Should have tried 3 to the 8. We were getting so close. Perfect. Okay, so now I know through some pretty good logic that 6,561 is 3 to the 8. And now you have to come up with something brilliant to figure out what n is. 3 to the 8 happens to equal 3 to to the n minus 1. What do you think n could be? That would make it 4. 9, right? If these are equal, does it make sense that what I circled in green has to be equal? And so something minus 1 is 8. And if you're struggling to see that is 9, yeah, we can talk. That's all good. So n would have to be 9. And so we didn't have any mathematical way to solve for this. Next year, you're going to learn that you could solve this using logarithms, but we don't know logarithms yet. But if you've ever wondered why one button on your calculator said log, it could help you solve this. We'll learn that next year. It's not too bad. But for now, this is all we could do. So I'm going to get you to circle questions 8, 9, and 11. And before